So this question is definitely a level harder than anything else we've seen so far. A 1.3 liter aqueous solution has a pOH of 12.35. What is the initial mass of HCl dissolved in solution given the molar mass of HCl? Okay, so this question, it's still going to have to work around our square. So I know I've got pOH, and let's see, HCl. Well, I guess I could write out the dissociation equation. Maybe that will help me. HCl goes to H plus and Cl minus. So yeah, that works. Somehow I need to go from pOH and get to H plus. I think the easiest way for me to do that would be to go to pH first and then go to H plus. Now you could do this going through hydroxide too, but again, I like to use this transition from pOH to pH because it's just 14. So let's see, pH is equal to 14 minus the pOH. That is 14 minus, there we go, 14 like that, minus the 12.35 we were told about. Okay, so 14 minus 12.35, that's 1.65. Neato. 1.65. And if I got 1.65, that's equal to my pH. In case you did this the other way, you'd get 4.46 times 10 to the negative 13th. That would be your hydroxide ion concentration. Either way, once you get there, you should be able to find the hydrogen ion concentration. So in this case, I'm going to take 10 to the power of negative 1.65. So using my calculator here, 1.65 negative, take that to the 10th power, and I get 0.2238. So my hydrogen ion concentration is 0.224. How do I know that? Well, that is just following the chart. So I've just moved from pOH to pH to H+. This has to be the hydrogen ion concentration. With that in mind, let's move over to a new slide so we have some more space to work. Okay, so we knew, just from the slide before, that our dissociation is H plus and Cl minus, and we knew from the page before that the concentration of hydrogen ions is 0.224 molar, moles per liter. You know, on that definition, molarity is moles per liter. So if this is a 0.0224, it's a one-to-one dissociation, then I can just solve for moles if I know liters. And the question tells me I've got 1.3 liters. Okay, well that's easy enough. I can just cross multiply. So x equals 0.0224 times 1.3. And if I type that into a calculator, I get 0.02912 moles of hydrogen ions. But the trick is, if I have that number of hydrogen ions, I also have that number of HCl moles because there's a 1 here and a 1 here. Well, if there's a 1 in each of those spots, then this is as easy as grams equals moles times the molar mass. Or, in this case, 0.02912 times the given 36.46 equals 1.06 grams of HCl. There you go, final answer. So definitely a bit more tricky, something you might see on the test. You're not going to see this on the quiz on Thursday, but it's definitely followable. You just have to kind of remember the trick. And I mean, as soon as you see this here, I think it flows pretty easily for most. Again, don't freak out like, oh, okay, I don't get this, Mr. Nettic. Yeah, understood. But in the long chart, it's really only one step further than what you're doing. It's just kind of backwards. So the first time you see it, you're like, this is a little different. But then it will click and you'll say, okay, this isn't actually terrible.